Now, figure 19-12 deals with sizing the overcurrent protection device for a feeder to allow a motor and other units, such as AC units, to start and run. Notice other loads could also be added in here if necessary for such a feeder. Now, if you wanted to size the conductors, you see figure 19-17. And that figure would show and illustrate how to size the conductors if need be. But now notice the overcurrent protection in the panel board. Notice 440.22B2 and 430.52C1. Now we have a motor involved here, see, and it's the largest, not any one of the air conditioner units. It's the motor that is the largest. So we have to go to our table 430.52 and select the percentage of an overcurrent device at 250% in the last column. And remember, using the table, you determine what type of motor. Is it an induction motor? In this case, yes. What is the design of the motor? Say it's a design B. What is the protective device we're going to use for the feeder? It's an inverse time circuit breaker. So the last column in the table, we pick up 250%, as we'll see. But notice 430.6A1, when motors are involved, refers you to table 430.250B to select the full load current of the motor based upon the voltage of the circuit and the horsepower rating of the motor. Now, with this information, we notice that we have a three-phase 208-volt motor, 15 horse, design B, and the total amps that we're dealing with is 25 and 23 for the AC units. The disconnecting means now we have 440.14 involved, 440.12, as well as 430.102 and 430.109, as well as 430.110. So with this information, we're ready to do the calculation to determine the size of the overcurrent device when a motor happens to be the largest on a feeder with air conditioners involved.